Today we're going to be learning about solving absolute value inequalities. We already started this yesterday, but today is going to be more complicated inequalities. So let's start with our steps for solving these inequalities. The first thing you're going to want to do is to isolate the absolute value and whatever stuff is inside it. So we want to get that absolute value by itself on one side of the inequality. Second, we are going to identify the structure. Now there are going to be two types of inequalities that we're going to be working with. One type is the AND inequality. The other type is the OR inequality. With an AND inequality, you're going to have the absolute value of your stuff is going to be less than whatever number you had. The other type would be the absolute value of your stuff is less than or equal to the number you're working with. So with the AND structure, it's going to be either the less than symbol or the less than or equal to symbol. So we'll want to keep track of that. The OR structure is going to be when you have the absolute value of your stuff is greater than a number, or the absolute value of your stuff is greater than or equal to a number. So the OR structure will have one of these two symbols. Now, it's important that you isolate that absolute value before you make that decision about which type it is. Once we've identified the structure, then we're going to go ahead and write our inequalities. If it's an AND type, we are going to write one compound inequality. Oops, I crossed my L. One compound inequality. And what that's going to look like is you're going to remove the absolute value bars. So you're just going to have your stuff in the middle. And you're going to keep that less than or equal to, depending. So this may be a less than or equal to. And on the other end, you're going to put a greater than, and then the opposite of that number. So on an AND, we're going to have one single inequality where our stuff is trapped in between a negative number and positive number. The OR inequality is going to be set up differently. With the OR inequalities, we're going to write two inequalities. So we are going to have the first one, we'll just take off the bars and leave that stuff is greater than the number. But then we have a second one, or the stuff, and what we're going to do is reverse the inequality to less than and then change the number to its opposite sign. So with the OR structure, we're going to have two inequalities. Remove the bars and write greater than the number and then the word OR, and then remove the bars and write less than the negative number. And again, if it was greater than or equal to, then these will be greater than equal to, less than equal to. Once we have these inequalities written, you're going to solve the inequalities and graph them on a number line. When we're working with the AND structure, we are only going to shade the region that is overlapping between our two inequalities. When we have an OR structure, you're going to shade both inequalities even if they overlap or do not overlap. So with the AND structure, you only shade the overlapping region. With the OR structure, you shade both inequalities entirely. So we're going to work a couple of examples so that you can see how these problems will play out. Our first example is going to be the absolute value of the quantity 3x minus 4 plus 5 is less than or equal to 27. So remember, our first step is to isolate that inequality. So I'm going to begin by subtracting the 5 over. And then I'll have absolute value of 3x minus 4 is less than or equal to 22. Next thing I want to do is identify the structure. So I look to this symbol, and then back from my notes, it's a less than or equal to. That's this kind, which makes it an AND. And then, since it's an AND, I'm going to write one compound inequality. So I take my absolute value bars off, and I write 3x minus 4 is less than or equal to 22. And then on the other end, I'm going to write the same direction symbol, like that, and I make it a negative 22. From here, I'm going to solve this inequality. Now, I don't know if you have worked with inequalities that have two ends. It's a bit different than equations, but what we're going to do is we would just kind of, if you imagine that you had this inequality, your first step would be to add 4, but now I have 3 sides, so I'm going to also add 4 to the left end. So then I'll have negative 18 is less than or equal to 3x, which is less than or equal to 26. And then, again, divide by 3, but I need to do that all 3 places here. So I get negative 6 is less than or equal to x, and x is less than or equal to 26 thirds. On my number line, I'm going to just put the values negative 6 and 26 thirds because I'm sort of a little bit lazy and I don't want to write out many more numbers than I have to. Maybe I'll put 0 on there just for reference. And then I'm going to shade the overlap. So what I've got is x is less than or equal to 26 thirds. So that would be a closed circle on 26 thirds, and I'm shading to the left. And then this one, when you read it from right to left, it says x is greater than or equal to negative 6. So I'll put a closed circle on negative 6 and shade greater than or equal to that number. Even though this shading would continue forever and this shading would continue forever, since it's an AND, I only shade the overlap, so it's going to just be in the middle here. So that's what my number line would look like. On our second example, we're going to follow the same steps, so we will isolate the absolute value first. So I'm going to start by subtracting the 6 from both sides. So I get absolute value of x plus 3 divided by 2 is greater than 4. Once I have that absolute value isolated, then I identify the structure. The symbol is greater than, which matches with the OR structure. So I'm just going to identify that as an OR. And then with an OR, what I'm going to do is write 2 individual inequalities. So my first inequality, I just remove the bar and write the inequality. X plus 3 divided by 2 is greater than 4. and then I write the word or, and then I take off the bars, x plus 3 divided by 2. I reverse the inequality to less than, and I change that to a negative 4. Now I'm going to solve each of these inequalities. What you'll notice is that your steps will be the same, but the result you get might be different. So I will start by multiplying both sides by 2. And what that does is cancels the dividing by 2. So on the left side I have x plus 3, and then that's going to be greater than 8. Or I do the same step of multiplying by 2, which cancels the dividing by 2, and I get x plus 3 is less than negative 8. I keep going, subtract 3 from both sides, and I'll also do that over here. So I get x is greater than 5, or x is less than negative 11. On my number line, when I have an or, I shade both inequalities. So I'm going to shade x greater than 5, which means I'll have an open circle, and then my shading will be to the right. Or x is less than negative 11, so an open circle on negative 11, and shading to the left. Now there are going to be 2 types of special cases that we need to talk about for these. And it's important, if you recognize them, it will save you time. But if you don't recognize them, you should still be able to work your way through it with some logical reasoning. Oh, let's spell correctly. 2 special cases. One of the special cases is if I have the absolute value of my stuff is either greater than or equal to a negative number. So what we know about this absolute value operation is that whatever number gets absolute valued will return a positive number. So when I have the absolute value of anything is greater than a negative number, that's always going to be true. So my special case there is going to be that the answer is all real numbers. Now the other special case is related to this, and that's when I have the absolute value of my stuff is either less than or equal to a negative number. And again, since whatever comes out of my absolute value has to be positive, then it can never be less than or equal to a negative number, so that would have to be no solution. I'll show you a couple of quick examples of that. I'm giving you basically the same example, but I'm reversing that symbol. Just like when we were solving before, it's really important to isolate your absolute value before you make a decision about what kind of problem it is. So you can see here, I'm going to need to divide both sides by negative 2. So on the left-hand side, I then have absolute value x plus 4. And on the right-hand side, I have negative 11. But I'm also going to have to remember that when we're working with absolute value, if you multiply or divide by a negative number, multiply or divide both sides by a negative number, you must reverse the inequality. So on this problem, when I divided both sides by negative 2, it's no longer a less than, it's now a greater than. So now I have the special case the absolute value of my stuff is greater than a negative number, which means the answer to this is all real numbers. So let's see what happens over here. Again, I'll divide both sides by -2. So on the left, I have absolute value of x plus 4. And then on the right, I have -11. Remember that when I divide by that negative, my symbol reverses. So I have is less than -11. Absolute value can never be less than a negative number. So this guy is no solution. I do want to show you one application of absolute value, and it has to do with tolerance and desired value. Well, what I'm going to do is show you how to set it up. But the type of problem that you could use this for would be, let's say I want the size of a pretzel to be at minimum, or I want the size of my pretzel to be 12 centimeters, and I'm willing to be wrong by 1 centimeter. Well, the 12 centimeters would be the desired value of the pretzel, and the 1 centimeter would be the tolerance that I'm willing to be off. So here is the way we would set that up, that we would do x minus the desired value, which in my case was the 12 centimeters, is less than or equal to the tolerance, which in my case was the 1 centimeter. Now, you don't always know the desired value and the tolerance. Sometimes you know the maximum and the minimum values. So to get the desired value, if you know the highest and lowest value, the way that you do that is that you take the maximum value plus the minimum value and divide it by 2. And the way that you get the tolerance, if you're not given that in a problem, is that you take the maximum value minus the minimum value and divide it by 2. So what I'm going to do is I'm going to give you an inequality for a tolerance problem, and then we'll figure out what the desired value is and what the tolerance is. Okay, so here's an example. And what we're going to do is write the absolute value inequality. That matches the compound inequality -15 is less than or equal to t, which is less than or equal to 45. So at first, it may be difficult to recognize that that goes along with this kind of a problem, but what we're given in this problem is a minimum value and a maximum value. So from our minimum value and our maximum value, we're going to be able to figure out the desired value and the tolerance, and then we'll be able to create this absolute value inequality that will match our compound inequality. So the desired value is found by taking the max plus the min divided by 2. So desired value equals max plus min divided by 2. So that will be -15 plus 45 divided by 2, or 30 divided by 2, which is 15. And then our tolerance is found by taking the maximum value minus the minimum value divided by 2. So our tolerance will be max minus min divided by 2. So we'll have 45 minus negative 15 divided by 2. Then remember that subtracting a negative means that we're adding those values. So we get 60 divided by 2. So our tolerance is going to be 30. It's a big tolerance. So when we write our inequality, then we're just going to create an absolute value. And we'll use the letter T because they used the letter T in the problem instead of the letter X. So we'll do T minus the desired value, which was 15, inside absolute value, is less than or equal to our tolerance, which was 30. And that will be the absolute value inequality that matches that compound inequality.